Hello there, I'm Professor Rad, and today we're going to talk about the product property of exponents. So let's get started by doing a little experiment. We're going to find 3 to the 5th times 3 to the 8th. Now, I kind of want to take a little shortcut if I can and find a more simple way of writing this answer. So what I'm going to do is I'm going to expand out 3 to the 5th. Remember that an exponential expression takes the exponent many copies of the base and multiplies them together. So since my exponent is 5, I'm going to take 5 copies of 3 and multiply them together. Cool. Now, if I wanted to find 3 to the 8th, now I have an exponent of 8. So I'm going to need 8 copies of 3 being multiplied together. Running out of room here. Okay, and then I'm multiplying these two expressions together. So notice that all that I have here is multiplication, and I've just got a whole bunch of 3's. So how many 3's do we have? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this whole thing is the same as 3 to the 13th power. What this means is if you have an expression where you have like 3 to something times 3 to something, you can write it as just a single 3 to something. Do you see how this 13 relates back to the 5 and the 8? If I take the 5 and the 8 and I add them together, I end up getting 13. And that makes sense because I had 5 3's here and 8 3's here. So when I add them all up, I get the 13. This is the product property of exponents. So let's zoom out a little bit here so we can see more of the page. The product property of exponents states that if you're multiplying 2 or more exponential expressions with the same positive base, then the result is equal to the base raised to the power that is the sum of the exponents. In other words, if the bases are the same and they're both positive, then you can add the exponents when you multiply. So for this example, we're going to see if this property applies, if we're in the right situation, and if we are, then we're going to use it. So for this first one, what we're looking for is we're multiplying things, which we've got, and the things we're multiplying have the same base, which we've got. So I'm going to use a check mark to indicate that yes, the property applies. So in order to apply the property, we're going to take that base of 6 and we add the exponents. So we need to add 3 and 5 together, and that gives us 8. All right, let's look at example B. So I'm looking to see that we are multiplying first and foremost, and I see that we're adding. So because we're not multiplying the two exponential expressions, the property does not apply. So if I wanted to simplify this, I'd have to figure out what is 6 to the 3rd and what is 6 to the 5th, and then add those two results together. How about part C? I can see already we've got a subtraction here. We don't have multiplication between the two bases. So no, the property does not apply. Okay. How about part D? I've got multiplication going on. Now, do I have the same base? Yes, I've got 2 4's. Now, don't let this negative mislead you. Remember, this is additive inverse, so this is not part of the base. If we had parentheses here, then it would be part of the base and we'd be in a different situation. So the base of both these expressions is 4, so we can apply the property. Our base for our answer will be 4, and then we add the exponents, 9, 10, and 11. Since we had this negative sign, this additive inverse, it just comes down and hangs out front of our answer. All right, now let's look at part E. So this is part of the multiplying two or more. So here we've got three numbers, and each of these are the same base, each of a base of 7, and we're multiplying all of them. So that means, yeah, we can apply the product property. So now we can add those exponents together. We're going to keep the base of 7, and then we have 2 plus 3 is 5. Now we got to do 18 plus 5. So 18, 19, 20, 21, 22, 23. So we get 7 to the 23rd power. How about this next one? In part F, we've got all multiplying going on, but notice now that each of the bases are different. We have a 2, a 3, and an 18. So since the bases are different, the product property is not going to apply here. Okay, let's do a few more examples. So for these examples, we're going to continue to write if I can say words today, write each expression with as few bases as possible. So let's start out with part A. We've got 2 to the 3rd times 7 squared times 2 to the 5th. So we're in a good place to use the product property because we have all multiplication. But as we saw in the last example, we need the bases to be the same. And not all of our bases are the same. However, some of them are. We have 2 that have a base of 2. So these two we can kind of condense together. That's going to be 2 to the 8th. 2 because the base is 2, and 8 because 5 plus 3 is 8. Then we're going to bring along the 7 squared. So this is written with as few exponents as possible. That's what it means for us to do here. Let's do a couple more. Here I have 3 times 5 cubed times 3 squared times 5 to the 5th. So again, we don't have all the same bases, but some of them are the same. For example, these 5s. We have 5 to the 3rd, and we have 5 to the 5th. So we can write that part with a base of 5 and add those exponents, 5, 6, 7, 8. Then I have two components that have a base of 3. I've got 3 squared and a 3. So that's going to be 3 to what power? Now be careful here, it's not 3 squared, because this part in and of itself is 3 squared, and now we're going to tack on another 3. So as a reminder, if there's no exponent written, it's presumed to be 1. There's an invisible 1 there. So 3 squared times 3 to the 1st is 3 to the 3rd. If we go back to where this property came from, that makes sense, because if you have 3 times 3 squared means you've got 3 times 3. And if I add another 3 to that, now there are 3 of them being cubed total. So one of the nice parts about knowing definitions over memorizing properties is that if you forget a rule, if you forget a property, you can always go back to definitions of what those operations mean to help check your answer. Okay, we've got one more to look at. So here I've got 2 squared and 2 to the 4th. So that's going to give me 2 to the 6th. Then I have a 3 to the cubed. And I've got a 5 to the 5th. And then I've got 15. Now I bet we can make this a little bit even more condensed. And here's why I'm thinking we can. I'm thinking we can because 15 is the same as 3 times 5. And I've got a 3 here, and I've got a 5 here. So we can condense this even more. sneaky one, this one. So we'll bring down the 2 to the 6th. Now I have 3 to the 3rd, and there's a 3 to the 1st hidden in this 15. So 3 plus 1 is 4. Then I have 5 to the 5th, and hidden in the 15 was a 5 to the 1st. So 5 plus 1 is 6. So 2 squared times 3 cubed times 2 to the 4th times 5 to the 5th times 15 is the same thing as 2 to the 6th times 3 to the 4th times 5 to the 6th. All right. You know what? That makes me wonder about one of the problems we did before. Let's look at this part F that we did before, where we said we couldn't apply the theorem here. And I'm thinking of this one because that 15 was the same as 3 times 5, and 18 can be broken down as well. Let's see. 18 is the same as 2 times 9, and 9 is the same as 3 times 3. So I can think of this 18 to the 7th as being 2 times 3 times 3 to the 7th. I wonder if there's something more we could do with that. For right now, I'm not sure there is, because I don't know what to do about these numbers that are in the parentheses being raised to a power. However, in a future video, we will talk about what we can do with this when we have numbers in parentheses being multiplied and the power on the outside. So we'll come back to this example later, but we don't have enough tools in our toolkit quite yet. So for now, here are some problems that you can try and see if you can apply the product property or not. If it does apply, then apply it. And if it doesn't, then don't. In the next video, we're going to take this product property and apply it to numbers that are in scientific notation. So, looking forward to seeing you then. In the meantime, have a great day.